We'll do 4.5 today, which means that next Tuesday we'll take a quiz between 4.1 and 4.5, and then we'll move on to 4.6. So today we're going to do 4.5, page 361 on your book. Graphs of tangent, cotangent, secant, and cosecant. We talked about sine and cosine, right? We said that the sine looks like this, starts from the origin, and it goes like this. Pi, 2 pi, where the period is 2 pi. It takes 2 pi to replicate itself, right? Okay, y is equal to sine x, this is y is equal to sine x. Okay. And cosine x is pretty much the same thing, except it doesn't start here. It starts here, right? And this will be now pi over 2. This would be pi. This would be 3 pi over 2. And this guy would be 2 pi. This would be the cosine graph, right? So this would be y is equal to cosine now. So let's go ahead and start talking about the graph of y is equal to tangent x. So y is equal to tangent x is really sine x divided by cosine x. If you look at it as a rational function, right? When we talk about rational functions, we said that at what points will I have vertical asymptotes? When what's 0? The denominator is 0, I would have asymptotes, right? Because I'm not allowed to do that, right? I can't divide by 0, right? I would have an undefined point there. Okay, so this is the cosine graph, which means that the tangent graph is going to have asymptotes when it's 0. When this guy is 0, every 0 point, I'm going to have an asymptote. Why the tangent, when I'm drawing the tangent graph, why it's the tangent, right? Okay. The graph turns out it's going to look like this. Okay. Better than that. Here's this guy. The graph looks like this, and it replicates itself. Unlike sine and cosine, where the period, it replicated itself every 2 pi. The tangent graph replicates itself. This is -1, negative pi over 2. This is pi over 2. So the period here is every pi, it replicates itself. Okay, it replicates itself. Okay, so the period here is going to be pi instead of 2 pi. Is it an even graph? If it was an even function, it would be this. Is it this? No. Is it across the origin? Yes, it is. As a matter of fact, it is reflective or symmetric across the origin. So it is an odd function. It's an odd function, right? Obviously not bounded. Right, it's not bounded because it can go with the positive infinity all the way down to negative. There's no boundedness there, right? Okay. So that's that. Blah, blah, blah. Domain is all real numbers except for multiples of pi over 2, right? Because every pi over 2, multiple pi over 2, right? Pi over 2, we're going to have an asymptote. Okay. The range is negative infinity to positive infinity. Continue. Yeah. Okay. All right. We're good. Any questions there on the tangent function? Okay. So let's kind of look at the cotangent. Okay, the cotangent is going to be what? Cotangent is going to be yes. So given that, our asymptotes are going to be in different places, right? because the cotangent x is now going to be cosine x over sine x. So I'm going to have asymptotes at where the sine function is 0, right? So let's start with the sine function and then try to build and get the cotangent function. Right? This is the sine function, which means our asymptotes are going to be whenever it's 0, right? And then I'm not going to go over there, but there is one there, right? Here, and here. Okay. And if you graph it, it's going to look like that. Again, the period is what? Pi, right? Pi, correct? And since it's going to look like this, is it symmetric across the y-axis? No. It's symmetric across the x-axis. I mean, the origin. Yes, it is. Okay, so it's an odd function again, right? Okay. You're going to have an asymptote at every pi, right? Pi, 2 pi, 3 pi, so on and so forth. Okay. Go ahead and look at example number 1. Let's see if we can do example number 1. So this was a cotangent, right? Example number 1. Describe the graph of the function y is equal to negative tan 2x. Y is equal to negative tan 2x. So we're going to start with the tan x. Y is equal to tan x, and we're going to do the transformation from this guy. Okay, so I will put the y over the negative over here. Okay, and I'm going to put the 2 like that. Okay, so where x was, I'm putting x over 1/2, which means it is a horizontal shrink for 1/2. Horizontal shrink of 1/2. Okay, and then where y was, I'm putting minus y, which means that I'm going to reflect it across the x axis, right? Okay, good. So that's that. Graphing a cotangent function. Describe the graph of in terms of the basic trigonometric function. So this is, again, kind of the same vein here. We're going to do example number 2. Y is equal to 3 cotangent x over 2 plus 1. Okay. So again, we're going to start with the cotangent x. Y is equal to cotangent x. We're going to move this guy around. Okay, so I'm going to move the 1 over, right? So I'm going to do y minus 1 is equal to that, which means I did what? I moved it up 1. Vertical stretch. No, horizontal stretch. I'm sorry, horizontal stretch, right? Up 2. And then this guy is what? Actually goes like here, right? So it's a vertical stretch of 3, right? Okay. Right. As you can see, these things just continue to build. This is stuff that we talked about in the P section, transformations and stuff like that. And these things just continue to come. Okay. All right. The next is the secant function, and we will do that after you guys got a crack at the homework. So let's go ahead and start working on the homework.